Both models show a perfect 100%. So, then who actually wins? We must calculate loss and count mistakes to find the truth.
Welcome back. And if you are first time here, I'm glad you found this video. We are actually talking about machine learning foundations, concepts at very beginner level to give you a very clear picture of what machine learning is all about. In the last video, we talked something about the classification. It was different from just getting a number, where the classification models were actually just deciding whether the prediction is correct or incorrect based on the actual values you got from various experiments. But we did not do one thing. We did not actually use the classification models to calculate the misclassification rate with actual data on how classification actually works. We just discussed the concept, but we did not get our hands dirty in actually calculating and finding out how this classification works. Because once you have that calculation and you see the calculation, the concept sticks in your mind. So that's what we are going to see in this video. Stick with me till the end so that you understand the classification concept in depth. Let's dive in. Okay, let's have a very quick recap of what we did in the last session. We discussed something called the classification, where the output was given by yi is a subset of +1 or -1. To put it simply, the output is always +1 or -1, which is decided by us. For what category we have to give +1, for what category we have to give -1. And the model is not bothered either if we give +1 to something or -1 to something. It just needs the misclassification rate, and we need to be consistent of what we are deciding. Okay. And we did something called the loss function. We also saw what is the loss function. We also saw this as misclassification rate. So classification, misclassification rate. So what we did, where the f of xi is the calculated, whether it is +1 or -1. Here there is no number, it is only +1 or -1. And this is the actual label which we got from experiment. Okay, for in case of houses, we always saw we take rooms, we take area. We will see the example below. So where we just need to know actual label, and this is the calculated label. So the number of misclassifications you add, and this is the one function where you add the number of ones and then divide by the total number of entries. Okay, so our task today, what are we going to do today? If rooms are going to be greater than 3, we are going to encode it as 1. As I told, it is going to be decided by us. We can keep it as, if it is more than 3, we can keep it as -1 as well. It doesn't matter. Okay, but here we have decided that if it is more than 3 rooms, we are going to classify at +1. And rooms less than 3 is going to be encoded as -1. Got it? Till then it's simple. Now, what is our data set? Our data set has 6 houses where area and price as inputs. That means what? We have 2-dimension data. In regression, we discussed in the initial example, we discussed with 1 dimension. That is, we took one of the properties of the flat or the house. Here we are going to take 2 dimensions. Here, if you see the example, you have the area, you have the price, and room label y. This is what it is actual. Okay, this -1 means what? The room was less than 3. If the area was 9, price was 5, and the rooms were less than 3. The second data point, where the area was 7, the price was 3.1, and again the rooms were less than 3. Here, the area was 12, the price was 6.9, and the number of rooms were greater than 3. Same for here. So everywhere it is greater than 3. Got it? So this is what is our data set. So you have understood what data set is. We have 6 flats we have taken, 1, 2, 3, 4, 5, 6. 6 flats we have taken, where we have taken the area and the price as 2 dimensions. Okay, and we have the labels. Now we have to take models and find out what they actually get, whether they get +1 or -1 is what we need to see. Okay, so we are going to have 2 models. The competition is between 2 models, like what we did in regression. We have 2 models who are going to compete. There is going to be only one winner. Both cannot be winners. If both are winners, then they are losing the game. Okay, so model F and model G. So these are the 2 contenders who are going to come and then find out their labels. It is +1 or -1 with their calculation, and see who is closer to the number of the misclassification rate is minimal. That model will be the winner. Got it? So now we introduce these 2 competitors. Who are the 2 competitors? one competitor, the model F, is the sines function area minus 10. That means what? If the area of the flat is more than 10, we are going to give plus 1. That means what it is going to assume, if the area is more than 10, that means that flat will have more than 3 bedrooms. That is what it is going to assume. Okay, so that is what is one model. So what is going to give? Plus 1, because that is going to assume sine area minus 10. If area is greater than 10, then it is going to be plus 1. That means what? Plus 1 is what we saw in the last slide, more than 3 bedrooms. Got it? So if it is more, the area is going to be more than 10. This model is telling was if area is more than 10, then it has more than 3 bedrooms. Got it? And if the area is less than 10, then it will be minus 1. That means it will have less than 3 bedrooms. We have the model G. Okay. So what it is going to do, it is telling price minus 6. What it is telling is if the price of the flat or the house is more than 6, then it will have 3 bedrooms. That is what it is going to assume. That is what this model is. So the algorithm, if we go little behind what the algorithm chooses many combinations of parameters, then finds out model, and each model it tries out till it gets the best model, right? So this model is price minus 6, sine price minus 6. That means if the price is going to be more than 6, then this model says was this flat will have more than 3 bedrooms. If it is less than 6, then it will have less than 3 bedrooms. Got it? So these are the two models. And now we are going to go and check with our data what we got in the last slide which I showed. I have just replicated the data here so that you can visualize it. So area is 9. Here if we put F, okay, the price was 5 and the actual label was minus 1. That means it had less than 3 bedrooms. Now if you see, the first model says area greater than 10 is plus 1. So it is 9. So we are going to have minus 1, right? And model G is telling if it is price is more than 6, it is going to be plus 1. Price is 5, so it will be minus 1. So we got minus 1, right? Similarly, next one, if you see, if it is 7, that is less than 10, so it has to be minus 1. The correct actual label was also minus 1. And the model G, price is less than 6, so it is price is 3.1. So again, it will have minus 1. Third one, 12 is more than 10. So model F will give it as plus 1, right? So if you see plus 1, the actual label was also plus 1. And the price was 6.9. And as per model G, if price is more than 6, that means it has to give plus 1. So similarly, if you see in each of the model, what we need to see is actual label and the calculated label of F and G. So if you see in all the cases, this is exactly the same. So in a way, what you are trying to tell here is both the models F and G are perfect, right? So there is zero misclassification loss. So that means we have got the best model in the world. But if you see what we started, the premise, models are just a replication of the actual world. An actual world has so many different parameters and criteria to decide on this. So if two models are exactly giving you with a very small data set, that means we are completely incorrect. You should understand that. You cannot have with 6 data points with just 2 models. If they get the correct answer, it doesn't mean you got the best model. Okay? If you remember the model definition, what I told you, models are always wrong. Some models can be useful, right? So that's what we started with. So if you're getting 2, that means there is some problem. If you see in the diagram, if you see all the 6 points are on the right side, right? Plus 1, plus 1, plus 1, everything is matching. So we have both model F and model G here, and both are getting all the results 100%. So that means we need a third player, because with these 2 players, we are not getting the correct answer. So let's bring in the third competitor. So let us introduce the third competitor, who is the model H. Okay, what does model H say? Price minus 9 will be plus 1. What was F of H? F of G, sorry. F of G was price minus 6. If more than 6 was the price, then we were giving plus 1. So we introduced the third model, price minus 9. So that means if price is greater than 9, the flats will have more than 3 bedrooms. If the price was less than 9, the flats will have less than 3 bedrooms. Okay, so +1 and -1. So let's go again to the table, the data, and we have the H prediction, the model H prediction also included. So you have the area 9, the price 5, this is fixed, the Y, the actual label, F predicted -1 correctly, G predicted -1 correctly, H also predicted -1, perfect. Okay, now we go to this 7, area is 7, so this was less than 10, so it will be -1, which is predicted F, and 3.1 was less than 6, so again G predicted -1, the actual price was -1 also, and our H model also predicted it as -1, perfect, because it is price is less than 9, so it has to be -1, so it is also 100%. Now the third case we will see, now area is 12, so it has to be +1 because our model was plus area plus 10 was 3. Okay, and price what was f of g? F of g was, if it is more than 6, it is +1. So these two both got correctly, and we have the actual value, this is plus. But let's come here. What happened here? What happened here is H predicted it incorrect. It was actually supposed to be plus, but it got -1. Because the model is, if it is price is more than 9, then only it has to be +1. But the price is 6.9 here. So if 6.9, so that has to be price is less than 9, so it will be -1. So that's good. So at least we got some difference. Now we go down and we see 16. All the three models get it as correctly +1. All the models, the price is more than 6, more than 9, it is 9.7. So everything is getting +1. Very good. Now come to 15. The price is less than 8.5. Because the H is related to price, we will specifically see the price. Okay. The model G +1 because more than 6. So it got +1. But here for H, it has to be more than 9. So it got -1. Similarly, 7.1. 7.1 is more than 6, but it is not more than 9. So again, it got -1, but the actual value, if you see in both the cases, you got +1. So the prediction is incorrect. So you have 3 incorrect out of 6. So the misclassification rate is 3 by 6, that is 0.5. This is as good as tossing a coin. What are the chances of getting head or tail? It is 0.5. So now we have 3 models, and what we told earlier, whichever the misclassification rate is the minimum, that is the best model, right? So now we have again, so in that case, the H is out because H is 0.5 and both F and G have 0. So now let's remove H. Again, we come back to the square one because F and G is the misclassification rate is 0. So that means what? Can we apply this 0 model to all the future rooms which we get or the flats which we get, and it will correctly predict? What do you think? That is exactly what we are going to do in the next session. Got it? So we will see how we break this bottleneck, because my assumption or rather intuition is that even though for the 6 sets of data we got all the predictions correct, if I have thousands of data, it is very difficult for the model to get all the 1,000 data correctly, right? So we will break this mystery in our next session. Okay, let's wrap up this session very quickly and see what we did today. We did 2 models and both the models got 0 misclassification rate. Then what did we do? That means we are not getting any concrete result out of this. Training data does not mean the model is perfect. So what we did do? We took a third model H, and what did it do? It gave a loss function of 0.5, which was very high, and it was not very useful for us because it is as good as flipping a coin. So now we are having a unresolved question. If F and G both are 0, then how are we going to choose? What happens if we test them on new unseen data? Are they going to still predict as they predicted here in the 6 data set as perfect with no errors, or they are going to start getting errors? So in the next session, we are going to see 3 new types of data. One is the trained data, one is the test data, and the third is the validation data. This 3-way split will solve our problems. I will leave you with one note. If we had our past papers, we can read them thoroughly And if we do the paper, we will get 100% result. But does it mean that the future paper which is going to come next year, which you are going to apply or reply actually, will you get 100% there also? Think about it. Think about it. We will meet in the next session and we will discuss how we break this situation and get the correct result from the loss function in the classification. Thank you so much. Take care. Bye-bye.